Okay, in this lecture I'm going to talk a little bit about data structures in Python, namely lists, tuples, and dictionaries. There are others, sets, and other things, but these are the ones that are most commonly used, and that's what we'll primarily use in this class. Just to start, there are a couple other resources. I still highly recommend, if you haven't already, working through the Python course at Code Academy. I think if you do that and spend 5 or 6 hours in that, you'll have a very good working knowledge of Python. Also, there's some more information about specifically what I'm going to talk about today, the data structures, on the actual Python documentation. And we may refer to this as I go along here, but let's just start off working through a few examples. We'll start with lists. So list is a data structure in Python. The syntax uses open braces like this, and so it's a way to just store a list of items. Those items can be integers, so if you look at what x is, they can also be floating point numbers, of course, and they can actually be a mixture of integers and floating point numbers, and even strings. And so they can be heterogeneous data structures. You can have a list of lists. So you can, by using an additional bracket, then you can have a list of strings simultaneously with a list of integers, for example. And so then you can use an indexing operation to extract items from a list. So if you wanted to take the first item from the list, and Python uses zero indexing, so the first item is actually the 0th item. So the first item of the list that I just put together is the list of strings itself. And then I can also index further into that, say, to take the first, which is really the second item. You should return the string of strings, of course, right? So you can also add items to the list, and there's a couple of ways to do this. So let's go back to just a list of, say, integers. So if we have something like this, you can use this syntax append, right? So if I want to append something to the end, like 4 to the end of the list x, then I have that. You can also insert, right? So I can insert here, and the syntax here, and if you need help, you can go to the data structure. So the syntax here is the index at which you want to insert, and then the value. And so here, if you want to insert, say, into the second index, the value 10, then I would just say 2, 10. And if we look at what x is, you have that. You can sort lists, right? So we can call the sort method on there. And now x has been sorted. And you can go on and look at the other things. You can remove items. You can pop item. That means basically to get the first item off the top of the list. You can reverse the order of a list. You can do other things like that. There's some additional shorthand for adding items to a list, particularly like if you had a list of lists. Like, for example, we had this previously. So again, x is this. I could then add another list to this list, right? So I can say plus let's add a list of floating point numbers to it. And so now you see that these items have been added on to the end. If I wanted to keep the same kind of list data structures, then I would use 2 brackets there, and then you see that now I have sort of 3 lists in one list, right? A list of strings, a list of integers, and a list of floating point numbers, and then I can of course index into that or do whatever I wanted with it, right? So that's basically lists. We'll use those for iterating later. We'll be looping over lists and extracting or manipulating values and performing operations like that. The key thing to note is that lists are mutable. Okay, and so lists are mutable. What that means is that you can change lists, right? We can reorder them. We can add values in the middle. We can add values into the end of them, and because of that, there's some memory and speed hits that we take over if we just had a constant. So in Python, there's something that can sort of be thought of as a constant list. This is not exactly true, but we can think of it as a constant list, and that is something called a set. I'm sorry, a tuple. Right? So it's a little more complicated what I'm saying, but you can think of as a tuple as a constant list, right? And so the syntax there is with parentheses. So if I have what sort of looks like a list, but I use parentheses, now this is a tuple. And now, if you see I have x1, 2, 3, then I can't use these kind of list operations on it. Like I can't append the value 4 to a list, to a tuple. It's going to give me an error because you can't modify it. And because of that, there's some memory and speed advantages to using a list. There is a very convenient way to extract items from a list, from a tuple, and that you can use this kind of fast unpacking. Right? So you can use this kind of fast unpacking. So where I have A, B, C, A comma B comma C is equal to X, then of course A will take the value 1, B will take the value 2, and C will take the value 3, right? So this is the fast unpacking there. I guess if we go back up here to lists, there was one more thing I wanted to mention. Lists support, well, let's go back here. Lists support a fancy sort of reassignment, and so what I can do here is I can reassign the 0th value of the list equal to some other list. And so then if I go here and we look at what list is, so initially list was, this list X was a list of strings, 1, 2, 3, and 1.1, 2.2. And what I did was I reassigned the first item, a list of strings, to another list, right? And that's because, again, lists are immutable. If we go back down here for the tuple, right, and so recreate my tuple. Now, if we try to do the same thing, say reassign the 0th index of the tuple to another value, say 4, then I'm going to get an error. Because again, in the end, the point is tuples are immutable. Right. Okay, so then last thing that we're going to use is something called a dictionary. And the syntax here, so dictionary are things that are like keyword argument, right? So I'll assign my dictionary, and the syntax uses now braces, and so I'm going to have a keyword string, and so in this case let's use like numerical, and then the argument will be something, right? And so in one case we could have 1 like this, and then the syntax to call back the value associated with numerical would be like this, right? And so that'll return 1. And of course then I could have numerical, alphabetical, and then the keyword here, the value here could be a string, ABC, for example, right? And so then should have a colon here. So then the way you would call that would be like that, right? And so again, then you can have dictionaries that are sort of dictionaries of dictionaries, right? So you can have that instead of the value of numerical, you could have another dictionary here. So, and it could have another keyword string. So in this case, say linear solver, and then, you know, GMRES, something like that, right? And so now, if I want to take my dictionary, look at what the value of numerical is. Of course, it's another dictionary, but if I wanted to actually go ahead and get the value of the linear solver now, you could do this and it would return GMRES. And go on like that. So we could build up very complex sort of nested dictionaries. And this is actually going to be quite useful in this class for building up input decks for our simulators.